Imagine stepping onto Mars for the first time. The sky looks butterscotch orange, the ground is covered in red dust, and the horizon feels strangely close. But as you take your first step, something feels different. Your body suddenly feels lighter, almost like you're bouncing. So the big question is, how fast could a human actually walk or run on Mars? To understand this, we first need to look at gravity. Gravity controls how heavy you feel and how your body moves. On Earth, gravity pulls you down with full force. But on Mars, gravity is only about 38% of Earth's gravity. That means if you weigh 70 kilograms on Earth, you would effectively feel like you weigh around 26 kilograms on Mars. Suddenly, your body becomes much lighter, and every step you take requires less effort to lift your legs. Because of this, walking on Mars would feel a bit like walking while slightly floating. On Earth, the average walking speed for humans is about 5 kilometers per hour, or roughly 3 miles per hour. But on Mars, the lower gravity changes the way we move. Instead of normal steps, astronauts would likely take longer, slightly bouncing strides. Scientists who study astronaut movement believe that humans could probably walk between 5 to 7 kilometers per hour on Mars without much difficulty. That's already a bit faster than normal walking on Earth because your body weighs less and requires less energy to move. But walking isn't the most interesting part. Running on Mars would be a completely different experience. When you run on Earth, gravity pulls you down quickly after each step. Your feet return to the ground almost immediately. But on Mars, because gravity is weaker, every push off the ground would send you slightly higher and keep you in the air longer. In other words, each step would feel like a mini jump. If you've ever watched astronauts move on the moon during the Apollo missions, you may have noticed they didn't really run normally. Instead, they used a kind of bouncing motion, almost like hopping. Mars has stronger gravity than the moon, but the same principle still applies. Instead of traditional running, humans on Mars might naturally switch to a loping or bounding style, where each step launches them forward in long, slow arcs. Studies suggest that with this motion, humans might be able to run between 15 and 25 kilometers per hour on Mars. That's potentially faster than many people can run on Earth. And if someone really pushed their limits, the reduced gravity might even allow short bursts approaching 30 kilometers per hour. But there's a catch. Mars has a very thin atmosphere, about 1% the density of Earth's air. This means there's much less air resistance, which might actually help with speed. However, the thin atmosphere also means astronauts must wear heavy spacesuits to survive. These suits are bulky and restrict movement, making running much harder. For example, the suits designed for Mars missions may weigh around 90 to 120 kilograms on Earth. Even though they would feel lighter on Mars due to lower gravity, they would still limit flexibility and make quick movements difficult. Because of that, astronauts would probably move more carefully, using controlled hops rather than sprinting. Another factor is the Martian terrain. Mars is covered with rocks, loose dust, and uneven ground. Running too fast could be dangerous. One bad fall in a spacesuit millions of kilometers from Earth could become a serious problem. So astronauts would likely prioritize stability over speed. Even so, the experience of moving on Mars would be incredible. Imagine taking a step and floating slightly forward before touching down again. Your strides would be longer, your jumps higher, and every movement would feel a bit like slow motion. In fact, because of Mars' gravity, humans could jump almost 3 times higher than on Earth. That means a jump that reaches half a meter on Earth could reach over a meter on Mars. This bouncing motion would naturally influence how fast we travel across the Martian surface. Future astronauts might even develop completely new ways of moving, somewhere between walking, running, and gliding. Some scientists think the most efficient way to move on Mars could be a rhythmic bounding stride, almost like how kangaroos move on Earth. If that turns out to be true, the first humans on Mars might not look like runners at all. They might look like explorers gently hopping across the red planet. And one day, when humans finally build colonies on Mars, children growing up there might move differently from us entirely. With lower gravity shaping their bodies and muscles, they could become natural Martian runners. So while the first astronauts may move carefully and slowly, future generations might sprint across the red deserts of Mars in ways we can barely imagine. The moment humans take their first true run on Mars, it won't just be a scientific milestone. It will be a glimpse into how humanity adapts to a completely new world.